Greetings, folks. I've had some questions on a wideband infrared Theremin prototype that I've had up on eBay, and I thought it'd be best to take a look at that in a video and explain a few things about it. For one of the first things probably we need to take a look at is in a conventional Theremin, you have two different antenna rods. An antenna on a vertical antenna on an oscillator, and then more of a loop-like antenna on another oscillator. And what those serve to do is the vertical antenna serves as a tone generator, and the loop antenna serves as a amplitude antenna for controlling the amplitude, and then of course you got your amplifier and speaker. And that's basically in the a top level overview. We'll discuss that a little bit more later, but that's how a conventional Theremin works, going back to its initial invention using vacuum tubes. And what I have for sale on eBay is the sensor, and we have an optical assembly here. The actual detecting element is located right here, and then over in this region, this is the amplifier, and there's a potentiometer here for adjusting the gain, and then over here is the output. The device operates on plus or minus 5 volts. There's an ambient temperature sensor output on there. I believe it's 1 millivolt per degree K, and then there is the output of the infrared sensor itself, which is about negative 100 millivolts up to about 300 millivolts. It's pretty low level. Now, the thing that maybe is where people are misunderstanding things is this is designed to attach to some external circuitry, and of course it also needs a power supply. And I've got a power supply up on eBay as well. This is a simple little supply, provides plus or minus 5 volts and also 15 volts. It's got an input here for either 120 or 230 volts depending where you're at, and you have to populate a second fuse if you're going to run it on 230 and change these jumpers around. There's also provisions for plugging in some external signal conditioning, because chances are your VCO or your VCA probably doesn't have a minus 100 millivolt to 300 millivolt input. It probably is a 0 to 5 or maybe even a 0 to 15. So you could plug a signal conditioning board into one of these jumpers if you wanted to do so. And as far as where it plugs into, this is an analog synthesizer. You can see all the patch cords and this, that, and the other sort of thing, where you'd be taking the output and running it into there. And if we look at the front panel, this is a voltage controlled oscillator, and the output of the sensor would go into one of these control inputs. Another thing a guy might want to do is use an Arduino, and this is a nifty little job. And one of the things that's cool is right over here. This is the USB to TTL converter chip. It's an FTDI. On the newer Arduinos, they actually went to an Atmel microprocessor, which can be reprogrammed. And what's nifty about that is you can take the output out of the main microprocessor here, send it to this guy, and emulate a MIDI port. And one of the cool things about doing that is that'll go right into your PC software without any or a whole lot of hoop jumping. You might have to play around with some drivers, but ultimately the thing is this is just a sensing element. It doesn't have an audio output or anything, and it requires some knowledge, expertise, and playing around a bit as far as how you want to hook the thing up. And that's about all that I wanted to say on this topic of the sensor itself. I'm going to make some other videos on the technical properties and why infrared might be a good choice, and some of the design headaches that one has to deal with in Theremin design itself. Thanks for listening.